Hi, in this video we're going to start putting our knowledge of the integrals of exponentials to work by tackling an application. Now our most common application in business calculus is going to be relating total quantities to marginal quantities. And now that we're in the section on integration as opposed to derivation, we will be given the marginal quantity and be asked to look for the total quantity. Okay, so a question that will use this knowledge, for example, is that suppose your marginal revenue in the units of dollars per item is given by MR is equal to 2e to the 0.02x. I have a bunch of questions for you to try to answer. First of all, what is the total revenue function? Second of all, what's the total revenue if I'm selling 50 items? Third, let's consider whether total revenue is increasing or decreasing, maybe a little of both for different values of x, I don't know. And likewise for marginal revenue. Is total revenue increasing or decreasing? And is marginal revenue increasing or decreasing? Now I wonder if you already know how to tackle this problem. I would invite you at this point to pause the video and see how far you can get without watching any further. Okay? I hope you're doing it and that you value the difficulty in trying to solve this without looking at the answer. Okay? First of all, for A, what was your overall strategy trying to find the total revenue given the marginal revenue? What do you have to do? Take the integral, exactly, because this is the derivative of that. So this is the integral of that, right? So then we're going to say that the total revenue function is going to be given by integrating the marginal revenue function dx. So we're going to start this problem by trying to integrate this function dx. Okay, so in the previous video you saw a lot of computational examples of this form, so I'm not going to go through it all the way, but it is a simple u substitution where u equals 0.02x, and usually we pull the 2 to the outside, and then through that u substitution, or by using the equation for the integral of e to the ax, you get e to the 0.02x divided by 0.02. Plus c, of course, right? So, plus c right there. Okay, you can check that. At this point, I would encourage you to, once you think you have the answer, go ahead and take the derivative of that answer. Make sure that you get what was in the integral back again. And then the rest of the problem for part A is going to be to figure out what the plus c is. Now, in previous problems like this, you may have noticed that the plus c often turns out to result in c equals 0. That happens a lot, but it doesn't happen all the time. So do not make the mistake of thinking that I can immediately say c is equal to 0 just because I know r0 equals 0. Now this fact right here is something that you always know. Your total revenue, if you sell 0 items, should be 0. Otherwise, it really wouldn't make sense where you're getting that money from, right? So I know this for a fact, but what I'm saying is this doesn't necessarily imply that the c is going to be equal to 0. It turned out that way a lot for the polynomials, but not as much for the exponential functions. Okay, so let's see how this solves it out for c. So 2 divided by 0.02 is 100. So I'm going to put 100, same thing as 2 divided by 0.02. And then e to the 0.02 times 0 plus c is supposed to equal 0. Okay, this is the statement that I get when I plug in the value x equals 0 into the antiderivative that I obtained, and then I set it equal to the output so I can see the relationship for c. Here's where it gets that c doesn't equal 0. Usually this term was canceling out quite a lot, right? But, okay, this is e to the 0, right? What's 100 times e to the 0? What's e to the 0? 1, right? It's not 0. In fact, e to the a is never equal to 0 for any value, positive or negative, of the exponent a. So this right here is 1 plus c is equal to 0. So I have the statement that 100 plus c is equal to 0, which translates into that c is equal to negative 100. You see that? C is not always necessarily equal to 0 when you're doing this type of marginal revenue to total revenue problem. Okay, so then my final conclusion for part A is that my total revenue function is going to be equal to 100 e to the 0.02x minus 100. And there's a couple ways that you can confirm that that is the correct answer. First of all, if you take the derivative of this, r prime, that's equal to marginal revenue. So the derivative of this had better match that. Go ahead and check that. Don't forget to use the chain rule, and you'll see that that works out. The other thing that has to work out to make sure your answer was right is the fact that r of 0 equals 0. So another check that you can perform is plug in 0 right here, and then you get 100 times 1 minus 100, and that would turn out to be 0. Okay, and that's a check of whether you did this step right where you used the initial value to solve for plus c. Okay, great. So then we answered question number 1. We can just check that right off our list. The total revenue function, which we call r of x, is equal to 100 e to the 0.02x minus 100. Hey, look at that. Look at that. The total revenue function has the same growth rate as the marginal revenue function. Remember what I was saying about exponentials? That's always the case. Okay, so now let's tackle questions B and C. And the question in B says, find the actual total revenue amount from selling 50 items. At this point, once you've completed part A, part B here is nothing more than a plug and chug using x equals 50, and you should get the number 171.83 cents. Okay, so this is just a calculator check. Please make sure that using your calculator, you're able to get this amount, and you're good to go there. C is what I really want to hone in on here. This is an understanding type of question, and it goes all the way back to the middle of the class where we defined what increasing and decreasing mean. Okay? It says, is the total revenue increasing, or is it decreasing, or is it a little bit of both? There's two ways that we can analyze this question in part C. The first way, maybe you like it more because a picture's worth 1,000 words, is you can plot that. You can plot the equation you have right there, and if you do that, you're going to see something that looks like this for positive x, okay? Now, if you just look at this picture, and if I asked you, is this function increasing or decreasing, what would you say? Increasing, right? It's going up, right? So it's increasing, and I don't see any parts of it that are going down, so I'm going to say it's actually always increasing. Look at that. It's always going up, right? The other way to confirm that r of x is always increasing is to look at its derivative, r prime of x. If r of x is indeed increasing, then what does that say about its derivative? That's synonymous to the fact that r prime is greater than 0, exactly. The derivative is positive because the slope of the tangent line is positive, it's always going up. So, well, that's funny. The derivative's right here. The derivative is equal to 2 to the O2x, just like that. Now, here's where it's going to come in handy for you to understand the review material on e to the a. What did I say about the number e raised to any number a? E to the a is always positive, right? It's never equal to 0, and it's never equal to a negative number. So e to the ax is always positive. 2 is a positive number. So this is a positive number times another positive number. So it's always greater than 0 no matter what x you put in. This is the algebraic way, or the analytical way, to confirm that your derivative is always greater than 0. And graphically, we see that it's always increasing. So your total revenue is always increasing when it's like this. By the way, what's the growth rate on this function? The growth rate a. That's equal to the coefficient of the linear exponent. Right, a is equal to 0.02. And that's a number that's greater than 0, right? So whenever the a is greater than 0, what did I say? Exponential growth. If the a is less than 0, exponential decay, always decreasing. If the a is greater than 0, exponential growth, always increasing. Right, so everything's tying in together. Isn't that nice? Okay, that was just an analysis of the total revenue, but the other part of the question says, is marginal revenue increasing or decreasing? Now, after all we've been through here, what do you think is the answer to this question down here about marginal revenue increasing or decreasing? Are you thinking increasing? I'm thinking increasing, right. And you know why? Because the marginal revenue is a functional expression which is exponential in form with a positive growth rate, right. So if I actually plotted the marginal revenue, it looks like when x is equal to 0 here, I get the number 2. So it has a different y-intercept. See, r of 0 is equal to 0, but mr of 0 is equal to 2. All right, they're a little bit different in that way, but certainly this is an exponential form with a positive a. So this is just like the thing it came from. This is going to be always increasing. And you can see that by looking at the graph. Or you can actually take the derivative of marginal revenue. So that would be the second derivative of total revenue. And you will also see that that's always greater than 0. And that follows the same exact logic here, right? Let's take the derivative just for practice. Okay, the second derivative of total revenue, the first derivative of marginal revenue, which is also the derivative of this function, just to check your practice. What's the answer there? 2 times e to the 0.02x. Is that what you got? What? I missed something? Oh yeah, sorry. Don't forget to multiply by the derivative of the exponent. Exactly. So that's the second derivative expression. The same logic applies. This is a number that's positive, another positive number, another positive number. So this is always greater than 0. So the lesson is, if you have total revenue that's exponential in form and that growth rate is positive, then it's always increasing. And its derivative is always increasing. And its derivative is always increasing. And its derivative is always increasing. And all the integrals are always increasing all the way up and down the line because they all have the same growth rate. And when the growth rate is greater than 0, that means your exponential growth, which is always increasing.